Welcome to this explainer, created by Forge College. Today, we're diving into the validation and observability of emitted events. Now, I want you to playfully put on your on-chain detective hats for this one, because we are going deep into the gritty underworld of smart contract events. You know, we've written our code, we've set up our logic, but now comes the real test, verifying that our evidence, our emitted events, actually matches what literally happened on-chain. It's a completely fascinating process, so let's get our magnifying glasses out and jump right in.
Here's our investigator's roadmap for today. We're going to quickly review the capstone context, see how to capture raw logs, compare expected versus observed data, fix emit mistakes, and finally, file the debug report.
All right, let's start with Section 1, the capstone context, focusing on event-driven logic. So, building directly on our previous lesson, implementing event-driven logic and contract functions, we have a specific goal. We need off-chain apps to actually trust our on-chain evidence. To solve this, we rely heavily on what's called the observable-sequence. Think of this as our suspect sketch, or a precisely drawn-up blueprint. It is the definitive technical design of what we expect the contract to do. It defines the strict, deterministic order of events and the exact shape of the payload. Basically, before we can even catch a bug, we absolutely need this baseline just to know what correct even looks like.
Moving right along to Section 2, capturing raw logs. It's time to collect our evidence.
Okay, so let's head straight to the scene of the action. First up, we use our local test runner, something like Hardhat or Foundry, to trigger a specific state transition in our contract. When that transaction executes, boom, it generates a receipt. Our second step is to very carefully extract the logs directly from that transaction receipt. Finally, we take those captured logs and write them out to a local JSON trace file. And just like that, this file becomes our collected evidence bag, sitting securely on our local machine, completely ready for analysis.
Now, it's absolutely crucial to understand what we are actually bagging as evidence here. We're capturing the raw log. These are the unalterable, permanent fingerprints left behind by our contract's execution. And they don't just give you nicely formatted human-readable strings right out of the box, no. They make you work for it. They contain raw arrays of topic hashes and low-level ABI-encoded data. It's the raw cryptographic truth of what just occurred on the blockchain.
Next up is Section 3, expected versus observed. Let's interrogate this evidence.
It is officially time to put our evidence under the bright lights. On one side, we have our expected trace artifact. That's our technical blueprint. On the other side, we have our observed trace file, the raw evidence we just captured. To compare these without completely losing our minds, we use a simple JavaScript comparator script. This script takes the raw evidence, checks the total number of logs, counts the topics, and compares the decoded data directly against our expected schema. If it returns true, our contract is innocent. If it returns false, well, we've got a mystery to solve.
And here is that exact forensic checklist in action. To be thorough, we map everything out line by line. We check the log count to ensure there are no extra or missing events. We verify that the number of topics matches, which means our indexed fields are correct. And we check the exact ABI-encoded data, like making sure the indexed ID genuinely matches 0x01 and checking if the newly stored value is indeed 42. When every single row in this table confidently says yes, we have achieved absolute 100% parity between our design and our execution.
Section 4, fixing emit mistakes and patching up the contract.
But hey, what happens when the fingerprints just don't match our blueprint? Well, that means our contract is essentially lying to the off-chain world. It's time to round up the usual suspects. Suspect number 1, the emit was placed before the state update. Honestly, this is incredibly common. Number 2, missing indexed values. You promised an indexed address in the schema, but you just forgot to pass it. Third, incorrect types. This happens when you pass something like a uint256, where the schema expects a much smaller integer, which completely scrambles the encoded data. And finally, non-deterministic ordering. This usually crops up when external calls cause reentrancy or internal shifts that mess up the exact intended sequence of events.
So, to avoid all that, you need to follow the golden rule of smart contract events. And the rule is this: you must always emit after the definitive state mutation. You update your mappings, you update your state variables, increment your IDs, and only then do you fire the event. This guarantees that when downstream listeners receive the log, they are getting the absolute, finalized truth of what is currently stored on-chain. If a listener queries the contract right after the event, the state should perfectly match the event they just saw. No exceptions.
Finally, Section 5, the debug report. Let's close this case file once and for all.
Okay, so we've caught the bug and applied the patch. But in professional Web3 development, you don't just quietly push the code and walk away. You create a concise debug report to officially close the case. Step 1. Document those failing logs, showing exactly where things mismatched. Step 2. Show the code diff, the exact lines of solidity you had to change. And Step 3. Rerun the tests and provide the output proving the comparator now returns true. This entire report proves to any downstream integrator that your emits were indeed broken, but are now flawlessly corrected.
By diligently capturing raw logs, performing strict comparisons, and strictly adhering to the golden rule, you ensure your smart contract is never lying to the off-chain world. Thank you so much for joining this explainer created by Forge College. Make sure you visit forge.college to continue your on-chain investigations and really master these Web3 topics. But before you go, I want you to ask yourself, if an auditor pulled your raw transaction logs right now, what story would your fingerprints tell? And more importantly, would it actually match the code you thought you wrote? See you in the next one.